This is Geometry, Unit 5, working on the interior angles theorem. What we're looking at is polygons. So before we get to this set of notes, we're going to look at what are some characteristics of our polygons. Well, we're all pretty familiar with a triangle, and a triangle has a sum of the interior angles of what amount? What does all three angles always add up to? You know that it adds up to 180. Well, if you take any four-sided figure, it doesn't really matter what it looks like. Okay, we'll call that a quadrilateral. And we're looking for what the sum of the interior angles are going to be for that. Well, there's one way we can do it, is to pick any vertex, draw the diagonal. So that's a segment that goes to a non-adjacent vertex. It goes through the shape. We've broken this into two triangles. Each triangle has 180 degrees in the interior, so their total sum is 2 times 180. Then we can go over to a five-sided shape. Call that a pentagon. Right, and we can pick any vertex you want. And you break it into 3 different triangles this time. And we notice that 180, 180, 180 is going to be 3 times 180. So that's going to be 540. And we can continue this pattern on for as long as you like. Here's another look at it with 6 sides, hexagon. And notice that we have even an extra triangle. So we have 4 times 180. So we go up to 720. And we could continue that with 7 sides, a heptagon, an 8-sided octagon, and 9-sided nonagon, 10-sided decagon. Continue. What pattern are you noticing here? This has n sides, 3 sides. And there is only one triangle. Here we have n equals 4. We have 2 triangles. N equals 5. We have a total of 3 triangles. Here n equals 6. And we have 4 triangles. What pattern do you see there? We're seeing that the number of triangles is always 2 less than the number of sides. 2 less than 3 is 1. 2 less than 4 is 2. 2 less, 2 less. So even if we go to a heptagon, that's 2, 3, 4, 5, 6. Well, not a very nice looking hexagon. Heptagon. Let me draw that a little bit different. There we go. That looks a little bit more like a possible 7-sided polygon. More obvious at least. Okay, nothing special about it, just 7 sides. So if we pick any vertex we want and we draw in all the diagonals, that means a segment to each vertex that is not next to it, and we're going to get the number of sides, which is 7, minus 2 gives us 5 triangles. And what do we know about each triangle? Each triangle is 180. So the sum of the interior angles of a heptagon is going to be 900. So the pattern we've noticed here is that n minus 2 is the number of triangles by the diagonals drawn from one vertex. Okay, that's the number of triangles that were formed. N minus 2 times 180 is the sum of the interior angles of any polygon. So that's a good recognition of what it takes to find the sum of the interior angles of a polygon. So we now bring this back to our notes, and what we learned is that the sum of the measures of the interior angles of a convex n-gon, so for any number of sides, is n minus 2 times 180. In other words, you're taking all the angles and you're adding them up, angle 1 plus angle 2 plus all the way up to whatever we have is n minus 2 times 180. So if we're looking for the sum of the measures of the interior angles of a quadrilateral, which is a four-sided shape, we would say that that's 4 minus 2 times 180. So that's 2 times 180. That's 360 degrees for the sum of the interior angles of every quadrilateral. A square, a rectangle, of course, they have 90. A trapezoid, a kite, parallelogram, all of them have the sum of the interior angles of 360. We'll come back to the exterior angle theorem. So now let's work with just figuring out the sum that we have here. You may have memorized it already, you already know, but just to kind of practice, one way you can do it is to draw the diagonals, look at the number of triangles, and say the number of triangles times 180. You could also look at it as the number of sides, and we always know that the number of triangles formed times 180 is going to be the sum of the interior. So we have 6 minus 2 times 180. That's going to be 4 times 180, which is 720 degrees. That is the sum of the interior angles. We'll jump down here to 3 before we jump over to 2. Let's take a look at this one. This is interesting. We have to figure out the two measurements. They're apparently the same because they have the tick marks. That's 1. We look at this as a 1 side, 2 sides, 3 sides, 4 sides, 5 sides. So n equals 5. So 5 minus 2 times 180, which is 3 times 180, 540 degrees. That's the sum of all of them inside. Well, we have the measure of angle K plus the measure of angle L plus 109 plus 105 plus 68, and that's going to equal our 540. Then we can go ahead and add those all together. We've got 100, we've got 268, 277, 282. So we have this x plus x, because they're the same, plus 282 is equaling our 540. If we subtract this 282 over, that'll give us 2 x's, and that's going to leave us with 258. Divide by 2. X will be 129. So each of these angles up here, the measure of angle K equals 129, and the measure of angle L equals 129. So what we did was look at the sum of the interior, which was 540, then we broke down all those different angles, collected our like terms, and found out for what we were missing. Let's try this one. There's something different about this one. Here we talk about the sum of the measures of the interior angles is 1,260. Well, that wasn't part of our list over here. That wasn't part of this. We only went up to 900. Well, if we do an 8-sided shape, and we draw in our diagonals, we can count them if we wish, but we know that an 8-sided is going to be 6 triangles. So n minus 2 times 180. Typically we put parentheses around the n minus 2. So we have 8 minus 2 times 180. So that's where that 6 is used for. So that comes out to 1080. That's not even the number we're looking for, 1260. As you may have guessed, if we go to a 9-sided shape, let's see if we can draw that. It seems crazy. And that's 1, 2, 3, 4. Let me slant it in a little bit. 5, 6, 7, 8, 9. A little ugly. I can't pretend it's not, but it's working out. Alright, that was our 9-sided shape. So if we take a vertex and we draw on the diagonals, really don't even have to do this. You could just take the number of sides minus 2 times 180. I think that's faster, but I'm showing you. 1, 2, 3, 4, 5, 6, 7. So the number of sides was 9. The number of triangles is 7. So the number of triangles times 180 is 1260. Well, that's one way we could do this. Just keep our table going up until we figured out exactly what it was going to be. Just kind of guess and check. Another way to look at it is n minus 2 times 180 equals 1260. If we divide both sides, it's more an algebraic format of doing this, we can figure out that 180 goes into 1260. A calculator helps. You get 7. Add the 2. So we get 9. So we could call that 9-sided. We could sometimes call that a 9gon. But one special name that you should know for a 9-sided figure is a nonagon. So this was one way to do it. The drawings was also another way you could do it. Just keep extending it up. You're going to get to a polygon if it exists to be a certain amount. Alright. Next we're looking for the exterior angles of a polygon. So the exterior angles are formed by extending each of the sides. An exterior angle is made by extending the sides, and we're only extending the sides at once per vertex. So it's got to be a continuation of the actual side. So this is a 4-sided figure. It happens to be 360, but that's more of a coincidence. It's a 4-sided, so it's going to be 360. Each of the exterior angles are going to add up to a certain amount. Is it always the same thing? Is it always changing? Is it the same as the interior? Let's take a quick look back here. When we talked about a triangle, we have 3 sides. We could look at a 3-sided. Let's make it just be real simple here. let's call it a 60-60-60, just to make life easy. And on the outside would have to be 120 because together they're a linear pair. Got another linear pair, another linear pair. So those three angles, 3 times 120, is actually 360. Well, what if you have a different triangle? And we extend the side, extend it, and extend it. If this is 30, or actually, let's draw them correctly, 30, 60, and 90. Well, this would have to be 120. This would be 90. This would be 150. And by adding those together, we've got 270 plus 90. Oh my goodness, that is 360. So the exterior angles again is 360. Well, go ahead and look at a rectangle. If they're all 90, for the inside, it would be a rectangle. On the outside, they're all 90. So 4 times 90 is 360. Okay, I haven't really gone through every shape to show you how this is going to work out, but the exterior angles is always, no matter what the shape, is always going to be 360. Okay, so here are the notes that we jumped over. The Polygon exterior angle theorem, the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360. It's always 360. That means the exterior angles are going to add up to be 360. To talk about a convex real quick, need to be sure we got all our vocab. Convex is going to be pretty much our normal polygon, whatever that means. Okay? So that's a convex. When you extend the sides, none of the sides go into the shape. That's convex. Pretty normal. What you would typically think about when you say a polygon. Concave that would be considered concave. You can extend the sides, and some of them won't go on to the interior, but there will be some that actually go into the interior, and that's a way to test. If you can't see the cave that's happening with concave, that you can extend the sides and you can notice it goes to the interior, where convex never goes to the interior. Okay, so that's the difference between convex and concave. We will always be doing convex polygons, all of our lessons, but they state that just to make it real clear for you. So we look at this. We know that it's the exterior angles. You got to be observant to that. We know the sum of the exterior. Sum of the exterior angles of a polygon. Okay, we could call that convex if you really want to be detailed about it. That's probably important. Is 360 degrees. So we're going to take our x plus our 89 plus our 2x plus our 85 and equal that to our 360. That's going to get me 3x. That's 170, actually 160, 169, 170. Let me do that one more time. Did I pick my numbers right? Yes, I did. We have 160, 169, 174. I don't remember that being the numbers, but that's what it shows to me. So we divide. 3 goes into that 5 times, with 2 left over. 3 goes into that 8 times. So it looks like that is 58 degrees. I've figured out where I went astray. It's 174 for sure, but it is not an equal sign. Where did that equal sign come from? Okay, so our equal sign is over here with our 360. That did not ring a bell. Alright, sorry about that. Hopefully you recognize the error. So now we subtract 174. We get our 6, carry it over. Alright, so now we divide by 3. And 3 goes into 19 6 times, with 1 left over. Rather embarrassing. I have to reduce my 6 to a 5, don't I? And then call that. So we have 86. Oh boy. And we divide by 3, so we get 62. Oh, I think I figured it out for us. Alright, good job everybody. Last one. Okay. So you go ahead, you work on this one, pause the video, and then come back to figure out how it goes. Alright, I have added up the number of sides that we have. So those 7 sides, that's a heptagon, minus 2 times 180 gives us 900. So the total sum should be 900. We're going to take our x plus 5, our 130, our x plus 30, 115, 140, 130, and x plus 20. Hopefully you've already done this. That's what was the request. Okay, we have 1x, we have a second x, so that's 2 x's, and a total of 3 x's. And just so we don't make another mental mistake here, we will use our calculator to help us figure out the sum of all our extra angles. So we have the 140 and the 130 and the 115 and the extra 30, the other 130, the 5, and the 20. Okay, so at 570. Now we have collected all our like terms. So we're going to subtract the 570. So when we do that, we can take 900 and subtract our 570. We get 330. And by dividing by 3, we get 110. 3 goes into 3 once, 3 goes into 3 once, and 3 never goes into 0. So you get 110. So that would be the value of x for this problem. First thing we needed to do is figure out the sum of the interior angles. It's different for whatever size shape that you're working with. And then you add them all up, equal them to the amount of the interior angles, collect your like terms, solve for x. Alright, enjoy everyone.